Hello, this video is about training a style for Stable Diffusion 1.5 and SDXL with LoRa, its concepts, and how it's different from object or character training in terms of data and training parameters, and how can we determine if our style is trained well or not and what to expect from it. The principles explained here apply to any style, regardless of what it was, art, clothing, or any type. We will also see a difference between using regularization images and without, and determine which option produced the better results. The style I'm going to train is a simple black and white sketching style, more like hand drawing, which is used in many illustrations. Now, this style, like many other in SDXL, is already learned and trained. Okay, so if we go to SDXL, we can see almost every style in the world. Every art style exists basically in SDXL, and could be produced by SD 1.5 with more prompts, however, with the right prompts. But using LoRa, we can make it easier and straightforward to produce such a style. Now, regardless how useful this style is, the principles are the same to create your own style LoRa. So let's begin. Now, first we define a folder, for example, for each type of objects, because I want to have some balance between the different types of objects that I want to train. For instance, I would have animal folder, building, city, person, clothes, electronics, plants, tools, toys, etc. Then we would go to Google, for example. Now, from Google, for instance, I look for a couple of pictures of vehicle drawing sketch. Usually, it's better to go to advanced search and click advanced search here. Then we choose the size, the image size, because we want to have larger image sizes if possible. For example, we can also choose the aspect ratio. For example, if we just want square images, then let's just select square images. This could help us reduce the necessity for cropping, but cropping in general is not necessary to begin with. Now, regarding the data set, I chose 400 pictures. These pictures are collected mostly from Google or various websites. Now, to prepare the folders, in the image folder, we would first put the images, our data. So usually if you are a style, we would put something like 2 to 4 or 3, for example, 2, 3, 4, approximately like this, number of repeats, and we can increase the number of books later to increase the number of the steps, because we don't want to learn the images themselves. We want to learn the style of this image. For example, if we put something like 20, this may result in learning the image itself and might not be very useful or very flexible. I will name it XYZ, for example, sketch style. Okay, the class images is style. Okay, now usually we could include the name, for example, the instance name, to have the same style name as that which exists in the Stable Diffusion checkpoint. This will allow to learn on top of that style. So it will learn that style using our images. So it will improve, something like improvement. If the style does not exist in the Stable Diffusion, we can, or we want to learn it anew, we can put an entirely a new name in this location. Then in the class folder, we can use regularization images, or we don't have to. For example, the regularization images must be of style for 1 repeat, for example. Here we can put, so for style images, we could use something like this, for instance, which are different styles of drawing. Now for the captioning, we go to the utilities. I will use WD14 captioning because it produces more information. We could also use blip, for instance, or other types of captioning. I'll use this because it seems to work very well with various types of checkpoints. We can here put a prefix such as XYZ, sketch style, so that this becomes a part of every caption at the beginning. Now, undesired tags, I will not have any undesired tags at the time being, unlike characters where I will remove anything that repeats. I will see what the caption produces, then remove it using another tool, which is, for example, I don't want to have anything related to my style, which is black and white, for instance, or sketching or pencil drawing. So I'll remove undesired tags later on. Okay, now let's start captioning and check the results. Now, after the tags have been generated, we can use a tool such as Borrow Dataset Tag Manager. Like I've said before, it has some bugs, but it's still useful. Okay, so what we need to do in this software, for example, I would check the things that relate to my art style, which is a monochrome with line art style, etc. So line art, I should remove this from the captions because I want this to be part of my LoRa. So I would come here and remove line art. Usually it would be good if we could review each of the captions, but that will take some time. I will not be doing this. I would remove grayscale, for example. Grayscale. I would remove monochrome. All these things, monochrome, grayscale, they are part of my art style. So I don't want them to be part of the captions because I don't want them to be changed. Once we are done, we save all the changes. We double check another button, sketch. Okay, let's remove sketch as well because that is something part of my art style. Sketch, save all. Why do I keep save all? Because this software has some bugs. It would be good to do save all every now and then to avoid losing my work. Okay. Now for the settings, we make sure that we go to LoRa section, to layer tab in Kohya SS. We can choose a certain stable diffusion such as 1.5, which could be more suitable if you want to use the LoRa on different checkpoints. For example, if I want to develop it on photon, I would use this checkpoint from here. For SDXL, I would check this option. For the folders, we need to select the folders. We choose the images folder. We don't go to, for example, here. We would go to the images, okay? We'll just select the image. We don't select this folder. Class folder, if we want to do regularization, the output folder as well. We give a suitable name. This name does not need to be the same as instance prompt. Often we would include the version, for instance, or whatever. For the parameters, I will train a standard LoRa. We could also train licorice. Licorice training, for example, if we would licorice locun, we just choose a suitable network rank such as 32, a suitable network alpha. These values, if we read, usually when we reduce the alpha, the training will be smoother. The convolution rank, we could use a 3 or 4, for example, and 1. Okay, I will train a standard LoRa, which is more used by people. Okay, we can use a number of epochs, for example, 10. Now, the number of epochs usually is related to how many steps we are targeting. For example, if I'm having 2 repeats with 400 images, that will be 800 steps per epoch. So if I have 10, I would target 8,000 steps. I could also use 20, for example, if I want to target higher number of steps. I don't want to train for a very long time and just want to test the results. And hopefully that in less than 10 epochs, we would get a flexible enough results. Okay, the captioning, I want TXT, I want to caption my images. For the mixed precisions, I would use BF, this is for RTX NVIDIA cards. For this, I can cache latence, I can cache the latence to disk because I want to train multiple models so that a small file is created. This will speed up the training each time we want to create a new model. For example, if I want to test the new settings, okay, let's check this point out. It will create another file for each image, okay. For the learning rate, I will keep it as it is, the schedule as well. We could use the same, the default here. We could also use add adapter, for example, for lower VRAM. I find the default settings seem to work pretty well. I will use 768. I will not be enabling buckets because I'm not having different resolutions. If we have different resolutions, we would enable buckets. Okay, I will use these defaults. We can go to the advanced. I will keep the advanced settings as they are. I will use clip skip 1 because I'm targeting realistic styles, and in general because for the sketching. Now 64 means that the images should be of multiplication of 64. Now here there's a noise offset. We can follow this recommended, okay, this recommended value. Let's follow this recommendation, for instance. Okay, I don't think that this value does affect the results that much. It's just experimental and we don't have much time to experiment with, so I will not do much experimentation. For the samples, now for these blocks and convolution, I will not go to them in the advanced section. Now for the samples, I will generate one sample every epoch. The goal here is just to see if my style is working or not during running Kohya. This helps us to know if we need to stop early or need to run till the completion of all epochs. Now I will use this command for example. It's a portrait of a young woman, for instance. We could also use for such as a landscape or well, whatever. Then I will say that in XYZ sketch style. Now, I just want to point out that the training lower dimension networks is much faster than higher dimension networks. For example, we can see here that we are doing 1.8 iteration per second for this dataset using my GPU, which is 8 GB RTX 3070. Now, in the middle of the training, we can check the results and see if they are acceptable. Okay, we can see that from first epoch it's learning, but this is more like a realistic picture. So this is more like it because I want something like a sketch. So this is epoch 3. This is really good. This is very good. Okay, epoch 3 looks really good. Epoch 4 is starting to get stronger. Okay, it's still a good result in general, but I don't think that we are getting better results anymore. We can see that these images do not exist in my dataset. All my dataset, these are all the women in my dataset because I have classified them initially into main categories. So I can see that it has actually learned the style of the images, not the images themselves. None of these images are similar to this one, only in style. So this is really good because I'm not learning the pictures themselves. And call this reg. Okay, I'll use the same parameters that I used earlier using the same seed here. We will not be going to epoch 8 maximum. We will go to 7, but I don't think so. Even 5 is more than okay. Let's go to 5 only. Okay, we will use the same settings and start training and check what will happen with the regularization set. We can see here that the number of steps is 8,000 because now I'm using 5 epochs and the regularization factor is 2. Now training with regularization has completed. I only trained for 5 epochs, 8,000 steps. We can see that the first epoch is not good. It's acceptable, but not good. The second epoch seems very good. Okay, the drawing style is really amazing. Okay, towards the 5th epoch, there aren't many changes between the 3rd, 4th, and 5th epoch, but the drawing style looks really good. And these images do not exist in the dataset, so I think that it's learning the style properly and it's not producing any colors either, despite that the classification images have colored images. Now, for the SDXL training, we basically use similar parameters to some extent. We just turn on the SDXL model. We select the base model. Now I'm running Gradio Live on RunPod, so the paths are slightly different. So I just select the SDXL base model. Now then I select the folders, the images folder, the output. I can use classification, or I don't need to use classification as well. So it's possible to train with classification images and without. Okay, so I usually recommend that we test both options with regularization and without and see which model produces better results. Okay, for now, I won't use regularization. I will only run for 5 epochs. I will use 2 repeats per image, 400 images. I'll use a seed of 1, for example. We can use the mixed precisions or the FP or BF. BF is suitable for NVIDIA training. I will be using a BF. Now, I will keep the defaults here. Adam works, I saw it to work very effectively. We could also use add a factor to reduce VRAM usage. If we are running, for example, on 12 gigabyte VRAM, for the macro resolution, we will set it to 1024 by 1024. As we said earlier, that we could use one of these resolutions. So the image resolution in the trained dataset is recommended to be one of these, for example. Now, if I have different resolutions, I need to enable buckets, but I won't because my dataset does not have different resolutions. I bought all the files with 1024 image resolution. I will keep this NOHAF VRE, which are the default for SDXL. For the network rank, we should use lower network ranks compared to the original SD 1.5. For example, if we have 128 in SD 1.5, we should put here, for example, divide by approximately 8. So we would put something like 16 or 8, and use a network alpha of 4 or 1 or something like this. This is entirely experimental. I saw that the values do work in general, really irrelative of the alpha value in general. But if we have lower alpha value, the training in general will be slightly smoother. For the advanced, now I won't be setting much in the advanced because my GPU is 24 on run board. If my GPU is 12, I would use a gradient checkpointing to reduce VRAM usage. We use Xformers. Now we could use this option in the additional parameters to train unit only, but I did not see this to produce much difference. Now one more thing that I keep forgetting in the advanced section, okay, it would be good to set a noise value based on the recommended values such as 0.05 or 0.375, which is more suited for SDXL training. Now regarding the instance prompt, we can use an instance prompt that exists already in SDXL and train on top of it. This will allow faster training and it will allow possibly better results. Okay, for example, if we are training a character that is similar to another character in the SDXL, we can put the name of the character here and it would allow to improve on top of our data, for example. Okay. Now this applies as well for styles. Now SDXL basically have learned almost most of the art styles there is. So developing this art style will not actually produce something of a great value because this art style already exists there in SDXL most likely. So as you can see, the training has started. Now I will test with this option with the unit only. Okay, like we've seen here, and may check without it as well. Now we will also make another test without unit and call it, for example, full version 2. We will keep the same parameters as before regarding basic parameters and everything else, and just start the training. Now to do the testing, we select the checkpoint, for example, photon for stable diffusion 1.5. Now I will use start from the first epoch and go to XYZ prompt. Okay, so the script is XYZ. I will choose search and replace for X horizontal axis and search and replace for Y vertical axis. Now what we will do is that we will replace this value with 0.2, 0.3, so we can test the 5 epochs. Then we will replace this value, the second value, which is called this one, with the same but with regularization. So I will compare between regularized output and without the regularization. I will use a random seed so that I can generate multiple images and without fixing the seed. So I think that is better. Now for the second test, I will test the same thing but with using different weights. Okay, for example, I found that epoch 2 and 4 look acceptable. So we can also put in the X, for example, just the weight from 0.0 to 1.5, for example, because this is a style, so we can apply it at higher strength than 1. So I generated a couple of pictures for each epoch. I can see that from the second epoch, we are getting good results. The epochs subsequently are not that much improvement. Okay, we can check the second one. The second epoch also looks good. Here as well, this second epoch looks good. It looks more like hand drawing. The colors are more sketchy. Okay. Now the second epoch here, all the epochs after the second epoch are good, but the second epoch I think it might be slightly more flexible. Next, if we test the second epoch, for example, and compare the results between regularization and without regularization, we can see that the full strength of the weight 1 is producing the best results. I see this looks more like sketching. Okay. And secondly, I can see that regularization is actually producing better results than without regularization. So this is the result without regularization. Here as well, we can see that regularization looks actually more like a sketch than without regularization. I would say that regularization, the results down here are with regularization images. So results with the regularization seem to produce better results than without. Here as well, we can see that with regularization, we are getting better results, better sketching. Here as well, okay, so I would say that the results are really good at weight of 1. and they could produce acceptable results after 1.5. We can see here, for example, if we mix it with another LoRa, that it's still able to give the effect to the second LoRa. At half the weight, it turns it into black and white approximately and changes the picture slightly. And at weight of 1, it makes it like a sketch, and it increases the sketch. So I think the results are good, and that our style is really acceptable, and that we have learned the style. Now, so regularization seems to give us a better effect. So we can further do several tests on different checkpoints, for example, different objects, and see that at weight of 1, it produces, sometimes it gives some coloring, for example, but this is normal in stable diffusion. But in most of the cases, it gives a black and white at full weight. Okay, here we can see that at weight 1 and 1.5 it produces good results. 1 and 1.5 it produces really good results. It looks more like hand sketching. Okay, so the results in general are really good. Okay, so it's even able to run at weight of 2, and it still produces objects. Sometimes the objects are not good, other times they look more acceptable than others. Okay, at weight of 2. So these are the results at 1.5. This is from Magic Mix. So the style can be applied on different checkpoints as well, not only on photon. So it has learned the style in general. We can see at 1.5 it's giving more like a sketch than 1 for a different checkpoint. Okay, this is more like a sketch despite using a different checkpoint. At weight of 2 sometimes it produces really nice results even with a different color. So regularization in general seems to produce more flexible results and is giving us the sketching and the style that we sought for, we started to do. Now for SDXL testing, we can see that for a sample prompt, we are getting the results from the first epoch. Not much difference between the various epochs. I would say that the second here. Now the difference between this one and this one it was trained with unit only. This did not use the network unit only option. I can see that without using the network only option, it's actually producing slightly better results. Okay, the results are not the difference is not big. Okay, it's very little, and it's difficult to actually make a sound decision. Okay, here we can see that the tree is basically the same. Here the tree has changed. So when training unit only, we are getting smaller file size, but the image style changes a little. Here we can see that's the second epoch, so we can see that the second epoch is the better epoch. Now running different tests using different strengths, for example, from 0.1 to 2, we can see that even at 2 we can get acceptable results. The changes are very little. Okay, this is style because it's already part of stable diffusion SDXL. We can see for a person, for example, at 1 we are getting a more sketch, like a sketch 1.5. It actually 1.5 looks better than 1. It looks more like hand drawing. 2, a very lousy hand drawing. So even at weight of 2 we are getting good result. Here as well we can see that this is with unit only, it's actually producing uglier result than the one here. This is without unit, so I don't think that having unit only option is making the results any better at all. So one should actually test it. All these are without using regularization. So if we use regularization, the results will be better than this, even just like SD 1.5, I think. Okay, so I think that we are learning the style even in stable diffusion SDXL, but this style, like I've said, already exists in SDXL. Okay, but this is like a slight change into it. So based on these results, we can make the final conclusion about this study, that first of all, so the principles that we have applied in this video can be applied to any kind of style. Like I've seen in this experimentation, that regularization is actually producing better results and more flexible results than without regularization, despite the ability of learning the style to an adequate level without the use of regularization data. So this is the conclusion. You can read it, you can pause the video and read the conclusion, and have a good day.